I want us to go and look at the slides that are prepared for you. It will make your life easier. Let's remember one thing. Euclid, the grade 11 part, is about the 10 theorems. The 2 that has to do with congruence, when you prove that. The 3 that has to do with center. The 3 that has to do with tangent. And the 2 that has to do with cyclic quadrilaterals. And I know where to look for solutions when I read the statement. Let's first remind ourselves about the parts of a circle. What do we call a distance around the circle? It's called the circumference. That line is called the diameter. Look at that line there. What do we call it? It's the radius. Look at that line there. It's not going through the center. It's called a chord. What does the chord do? It divides the circle into 2 parts, the major segment and the minor segment. There is a major arc and the minor arc as well there. The one on top, this one is called the bigger arc. And this one below is called the minor arc. Minor arc, the smaller arc, minor arc. What do you call that piece of pizza that is formed by the radii? This piece is called a sector. A sector, minor sector, small piece, and a bigger piece and a bigger sector there. Look at that line here. What is the name of that line? That touches the figure at one point. That line is called a tangent. This one is also called a tangent. Let's put it in there. That one is also called the tangent. All these lines are called tangents, as long as they touch the figure at one point. These are the theorem, Converse theorem, chord bisector. A line drawn perpendicular to a chord and passing through the center of a circle bisects the chord. We've got a line that is drawn perpendicular to a chord. What does it do? It bisects the chord. It makes this side equals to this side. Right, it bisects the chord. That theorem is important. An example, if you go to the exam and we're trying to find the length of OS, where is OS? This is OS. How do you go about doing this? Applying this theorem. Because we've got the same scenario. We've got a line that is drawn from the center of a circle perpendicular to this chord. What does it do? It bisects the chord. So this side from S to the center is the same as from here to the other side. If this whole distance is 8 centimeters, if I don't know this theorem, I will never see that the distance from here to here is 4 centimeters, because this line bisects this chord. So if it is 8, so this line from there to here is 4 centimeters, and this one from there to there, it is 3 centimeters. I'm looking for that one. Now, what type of a triangle is this one? It is a right angle triangle. How do we go about finding OS? You use your grade 8, grade 9 theorem, Pythagoras theorem, that OS squared is equal to this side squared plus that side squared. If this is 3 squared, this is 4 squared, which is 16. This will give us 25. So that side, S squared will be 25. SO squared will be 25. Therefore, SO will be 5. So that becomes important using the Pythagoras theorem, that OS will be equal to 5. The terminology is important. That simply means subtends. We've got arc AB subtends angle X where? At the center. That's how you read it. Arc AB subtends angle X at the center. Arc AB subtends angle Y at the circumference. I'm introducing the center theorem now. Whether the arc or the chord, it does the same thing. Chord AB subtends angle X at the center. They can be subtended by the arc or a chord. The same chord subtends angle X at the angle Y at the circumference. This theorem, the center theorem, this one is 2 times bigger than that one. It doesn't matter where it comes from. It can come from any position. This arc forms this angle. If the same arc can form another angle at the circumference, that one will be half of this one. That one is at the circumference. So this one is half of this one. If I want to equate these two, Y and X, I've got to multiply this by 2. Arc or a chord does the same thing. It doesn't matter. I can take it from this side. Right? This is AB, subtends at the center. Let's take this, it's the same AB to the circumference. Let's look at it. We are taking AB to the circumference. Therefore, this one is 2 times bigger than this one. center theorem. Arc or a chord does the same thing. Let's look at more problems. This is the 8 different ways in which the center theorem can come out. We know this standard position. The angle at the center is twice the angle of circumference. So this arc forms this angle at the center. The same arc forms it at the circumference. I hope you see this one. Arc goes to the center. The same arc goes to the circumference. Let's look at the third one. This is my arc. This is my arc. It goes to the center. The same arc goes to the circumference. So this one is 2 times bigger than this one. Let's go to this one. This is my arc. It goes to the center. The same arc goes to the circumference. So this one is twice that one. You don't always expect it to come this way. It can come in 8 different ways. Let's look at this one. This is the arc, goes to the center. The same arc goes to the circumference. Remember, this is 180. If this is 180, therefore that one will be 90. Let's look at this one. This is the arc. This is the arc. This arc goes to the center. So this angle here. The same arc goes to the circumference. It's that angle here. So this angle and this angle. So this angle is 2 times bigger than that one. So you must be able to see it no matter how it comes in these 8 different ways. These are all center theorem. So what is this saying to us? If the angle at the circumference is x, what will be this one is? What will this one be? If this one is x, what is that one is? It will be 2x. So the one at the center, this one, is 2 times bigger than this one. So that's important. I must be able to see the center theorem no matter how it comes out. The angle subtended at the center of a circle by an arc or a chord is twice the angle subtended at the circumference by the same arc or chord. We say angle at the center or center theorem when you abbreviate it. I want us to take a few problems on this. Find angle x there. What is it that I notice? I notice the theorem. Nothing is being asked here by the theorem. This is the angle at the center, that is the angle at the circumference. Which one will be big? The one at the circumference or the one at the center? Yes, the one at the center. If this is 84, what is x? It will be half of that, which will be 42. Angle x will be equal to 42, reason angle at the center. Let's look at y here. This one is at the circumference, this one is at the center. Which one is big? This one is 2 times bigger than the one that you see. If this is 35, what is y? It will be 2 times 35, in this case which will be 70 degrees. That's how you go about applying these theorems. That says the angle at the center is twice the angle of the circumference. Let's look at these ones as well. The angle at the center is twice the angle of the circumference. That's what I know. If you focus at what you know, you'll never go wrong. What is this question? The first one is asking for angle x. Where is angle x? X is here. How do I find x? I try and look up, I don't see the value, then I'm stuck. But I know that this distance from here to here is the same as the distance from there to here. What do we call that? Radius. Now, this makes this the type of a triangle which is called isosceles triangle. So if this is x, because these two are the same, OA is equals to OB, radi, therefore this angle here, 42, will be the same as this one, because angles opposite equal sides are equal. So if this is 42, this angle hidden here will be 42. And I know that the sum of interior angles of a triangle are supplementary. If I know that this one is 42, this one is 42, I can't be able to find x, because this is x plus 42 plus 42 give me 180, and eventually I will find x to be 96. I've used the isosceles triangle and the sum of interior angles of a triangle. The fact that OB is the same as OA, it makes this triangle OAB an isosceles triangle. If this is 42, then this one will be 42, then 42 plus x will give me 180 degrees. Then I say 180 minus 2 times 42, which will give me 96 degrees. So the value of x is 96, and x is at the center. I can find the value of y, because this one is 2 times bigger than that one. So to find the value value of y, I take this angle, which is x in this particular case, I divide it by 2 to find the value of y. In that case, I will find my y to be 48 degrees because I've used the center theorem, angle at the center. This one is twice than that one. If this is 96, therefore that one will be half of 96, which is 48 in this particular case. Let's look at the next one. But before that, let me share with you my theorem. There's a theorem that I discovered. The theorem says the angle between a radius and a chord plus the angle subtended by that chord are complementary. What am I saying? I'm saying this angle that is here, that is between a radius and a chord. It can be this one, a radius and a chord, either of the two, because this is 42, this is 42 as well. So whenever we've got an angle between a radius and a chord, plus the angle subtended by that chord at the circumference, you will always have 90 degrees. But don't apply this theorem yet, it's not approved. This angle plus that angle is equal to 90 degrees. Look here, if this is 42, what should we add to get 90? We should add 48. So it is exactly the same thing. So this angle plus this angle must be equal to 90. I see the same thing even here. So this angle plus this angle must be equal to 90. So it will make it easier to find that angle. So don't apply the theorem yet until it is approved. Right, let's look at angle P. This is angle P. All that I want you to do when you have a problem, look at the theorem. I can see the center theorem here, so the angle at the center, this angle P, is twice the angle at the circumference. If I've got that one, all that I need to do is to multiply this by 2 to be able to find P. So P is in actual fact 62 times 2. Mistake that we do, we'll say P is 31. So P is 124, center theorem, or angle at the center. If I've got P, I know that Q and this one are the same. So I've got Q plus 124 to get 180. And I've got only one known, which is Q. I can find Q to be equals to 28 degrees. If you use my theorem, 62 plus 28 will give you 90. So this is 28. That's how you can find 28. Right. I want us to move to another theorem quickly. The angle in a semicircle is a right angle. As I say the angle in a semicircle is a right angle, I should know that it's the angle subtended by the diameter. Let's make an example. This is the diameter, half circle, semicircle. Semicircle, semicircle, semicircle means half of the circle. So it passes through the center, which is the diameter. Forms an angle. The angle subtended by the diameter is equal to 90 degrees. So even if it does not look like 90 degrees, as long as it is formed by this diameter, it will be 90 degrees. Look at this one. This diameter also forms that angle. Let's form it here. This diameter also forms that angle. So no matter how it looks like, this angle here must be 90 degrees, that angle there is also 90 degrees, and this angle here is also 90 degrees, as long as it is formed by the diameter. If I'm given this problem, find the unknown angles below, stating reasons. So reasoning is important. This line goes through the center, it is the diameter, so I think of this theorem. Now watch, this one subtends angle A, and I'm required to find angle A. So what is angle A here? It is 90 degrees because it is subtended by the diameter or angles at the semicircle. Look at B. B is here. This is a diameter. It forms this angle. So all the time diameter would subtend an angle which is equal to 90 degrees. Hence the value of B will be 90 degrees angle in a semicircle. Let's look at C. This is what C is. What is this called? It's called a triangle. What is the sum of interior angles of a triangle? Remember, we've already found B to be 90. Angle B is 90. So we've got 90 here, we've got 70 here, we're short of that. Once we've got 190, we are short of another 190 to give us 180. So this is 70, so definitely that has to be 20. So 20 plus 70, it's 90, plus this 90 will be 180. The sum of interior angles of a triangle are 180. If we've got 70, we've got 90, we are short of 20 to have 180. So the value of C here will be 20 degrees. It has to be 20 degrees. The sum of interior angles of a triangle. Let's look at D. This is where D is. I look where it comes from. It is formed from that triangle here. And this line is the diameter, the angle and the semicircle, or subtended by the diameter. It forms an angle of 90 degrees. So D will be 90 degrees. Let's look at E now. Let's look at this angle E. I know that this is a triangle, this is a triangle, this is a triangle, this is a triangle, this is a triangle. So 90 plus 30 plus this angle gives me 180. We already have 90, another 90 will come from 30 plus 60. So this E must be equal to 60 degrees. So that's how you go about applying these theorems. Let's move on to another theorem. Angles subtended by an arc or a chord in the same segment are equal. Angles subtended by an arc or a chord in the same segment are equal. Let's quickly look at it. This arc subtends that angle there. The same arc subtends another angle there. Let's create the third one from the same arc. It doesn't matter, it doesn't have to be only two. I can have another one there. So all these angles, this one, and this one, they are all formed by this arc. We can all refer to them as the same. If this is x, that will be x, and this will be x. So they are subtended by the same arc, therefore they will be equal. It can be the arc or the chord. It does the same thing. Doesn't matter it comes from which position. This arc forms this angle. The same arc forms another angle here. Therefore, this angle will be equal to that one. If this is x, this will also be x as well. I can also come from this position. I can also come from this position and form that one. And this position form also this one. It can be y's. So those two will be the same if I'm coming from this position. It can be the arc or the chord. The chord that forms these two angles, which are the same. Angles subtended by an arc or a chord in the same segment are equal. So this one equals to this one because they come from this arc, or if I'm coming from this side, this one will be equal to this one. These two will be the same. Look at this angle. It's 38. It comes from this chord or arc. This chord forms that angle. The same chord also forms that angle. So this one is also 38. And this one will also be 38 because it is subtended by the same arc or chord. Yeah. This is the arc. This arc forms that angle. The same arc forms this angle. So these two are the same. In the very same way, if I'm coming from this side, that one is y. So this one will be 40, therefore y is 40 as well. Angles subtended by an arc or a chord in the same segment are equal. And let's go to the cyclic quadrilateral theorems. There are only two. The angles, the sum of opposite angles of a cyclic quadrilateral are supplementary, or they add up to 180. The sum of opposite angles of a cyclic quadrilateral are supplementary. Let's create it. That's a cyclic quad. These are the two angles that I'm talking about. The theorem says if I add these two, I will get 180. So y plus w is equal to 180. It cannot only be these. Even if we have angles here, these two angles, when I add them, I will also be able to get 180. So angle x plus angle z is equal to 180. This is what we check in a complicated diagram. If we do have opposite angles of a cyclic quad, we add them, it should give us 180. If I've got this one, I'll be able to find the other one. It doesn't matter how it looks like. Even if it might look smaller than this, as long as all four corners of a quadrilateral touches the circumference, it will be concyclic. It might look half of it. This is still a cyclic quad. 1, 2, 3, 4. It touches all four corners. 1, 2, 3, 4. So this plus that will be equals 180 degrees, or these two also equals to 180 degrees. And you must be able to prove this theorem. If I'm proving that this plus this is 180, the construction will come from these two. Let's look at, for example, of the same theorem. Let's look at it. Angle x. This is where angle x. What do we have here? We've got a cyclic quad. This is a cyclic quad. Cyclic quad, cyclic quad, cyclic quad. All right, let's work it out. I know that this angle plus this angle give me what? 180. Reason? Opposite sum of opposite angles of a cyclic quad. So if this is 85, the value of x there will be 95, because 85 plus 95 will be equals to 180 degrees. The mistake that we do as young learners, if I see 85 here, I will assume that is also 85. They are not equal. When I add them, I must get 180 degrees. So it's 85 plus 95, that will give me 180 degrees. Let's look at y. This is a cyclic quadrilateral. So this angle here, y plus 110, will give me 180. If this is 110, I need to add y to give me 180. What is this y? What is 110 plus what will give me 180? This should be equals to 70 degrees, because 70 plus 110 will give me 180. So the value of y should be equals to 70 degrees. So 110 goes with 70, 85 goes with 95. When we add, I get 180 degrees. Let's look at P. This is where P is. Remember, I said to you, you must be able to see the stuff, the basics that we've done earlier on, even in a complicated diagram. What do we call these angles in a straight line? When I add these two, what do I get? 180 degrees. So 135 plus P must give me 180 degrees. So if I'm looking for P, I will say 180 minus 135 to get P, which is equals to 45 degrees. So I've already found P by using my grade 8, grade 9. I don't lose sight of my basics. The sum of angles in a straight line, they are supplementary. So P plus 180, P plus 135 is equal to 180, hence P will be equal to 45. I've used a straight line. Let's look at Q. Is this a cyclic quad? Yes, it is a cyclic quad. What do I know about the sum of opposite angles of a cyclic quad? They are equals to 180. If I've got 70, 70 plus what will give me 180? Let's go back here. Y plus what will give me 110? Y plus 70 will give me 110. So y goes with 70, 70 goes with 110. Now I'm giving you 70 here. What should be the value of Q? It should be 110, because if I add Q and 70, I will have to have 180. So the value of Q, angle Q, therefore, must be equals to 110. Opposite angles of a cyclic quad. Let's look at R. Let's read the theorem. An exterior angle of a cyclic quad is equals to an interior opposite angle. This is exterior angle. It will be equals to the interior opposite angle. In this case is R. The exterior angle is equal to the interior opposite angle, which is R in this particular case. So R will also be equals to 135 degrees. The exterior angle of a cyclic quadrilaterals. Let's look at other theorems. The tangent is perpendicular to the radius at the point of contact. Tan radius theorem. So if we've got a radius, and let's draw a tangent here, and a tangent, I should all know that this is 90 degrees or this is 90 degrees. I don't have to be told that this is 90 degrees. It doesn't matter where it comes from. I can have a tangent there. I must be able to see that that angle is 90 degrees. Even if I can have another tangent to this side and draw a radius from there to there, 90 degrees will be formed there. I don't have to be told that this angle there is 90 degrees. So the angle between a tangent and a radius is 90 degrees. Tan radius theorem. The angle between a tangent and a radius is always 90 degrees. Right. What is important is that when we do these problems, don't be lazy to read the statement, because the statement will take you towards the solution. Now, if OT is a radius and AB is a tangent, that's important. If OT is a radius, OT, this is a radius, and this is a tangent. Whenever a radius meets a tangent, 90 degrees is formed. So there's something hidden here for us that will make us to say mathematics is difficult. But the solution is here in the problem. We are told that OT is a radius and the other one is a tangent. Do we have a theorem that deals with the radius and the tangent? Yes. Whenever a radius meets a tangent, 90 degrees is formed. So the question is not actually asking for x. It's checking whether I know the theorem. X is thrown there to put you away from the actual question. The question is asking whether we understand that this is 90 degrees. Because after that we'll go to grade 8, grade 9. This angle plus that angle plus this 90 which is not there, which you must be able to imagine. This 90 will give me the solution of x. Because x plus 90 plus this one will give me the solution to find x. Because when I add these three, I'll get 180. So x will be then with 54. 54 plus 36 plus 90 will give me 180. The sum of interior angles of a triangle. I've used the fact that I've got a tan radius and the sum of angles in a triangle. This is a radius and a tangent. This 90 was very important because I wouldn't find the x if I did not see the theorem first. So x there is trying to throw you off from the actual question that is being asked. All that is being questioned in Euclidean geometry are the theorems. So I'm checked whether I understand that this is 90 degrees, then it will make my life easier. What angle is this? This is y. Don't look at y, look at the theorem that you might find there. What is the name of this line? This line is the diameter and it subtends the angle y. This diameter subtends the angle at the circumference. Therefore, angle y will be 90 degrees, angle in the semicircle. Then the last one will be z. We've got 30, we've got 90, we've got z. They must give me 360. 360 is made out of two 90s. This is the first 90. Let's find the second 90 between these two. If this is 30, therefore this should be 60 to give me the second 90 to give me 180 altogether. So z must be equal to 60 degrees. So that's how you go about solving problems. Look at the next one, two tangents theorem. As I say two tangent theorem, you must be able to see the diagram. If two tangents are drawn from the same point outside the circle, then they are equal in length. Let's do the scenario. If this is P, let's draw a tangent from P to the diagram. That is the tangent. Let's draw another tangent. That is the tangent. If two tangents are drawn from the same point outside the circle, then they are equal in length. Now, don't misinterpret this theorem and say it says PR is equals to PU. Those are lies. These tangents are equal up to the contact with the circle, not beyond. Up to the contact with the circle. So PQ will be equals to PT, or PT is equals to PQ, not PR. They are equal up to the point of contact with the circle. So PT is equal to PQ. PT is equals to PQ, not PU equals to PR. That's lies. They are equal up to the point of contact with the circle. Let's have another scenario so that we understand what we're doing. Let's look at this one. PT is equals to PQ. There are two tangents drawn from the same point outside the circle. Those are the same. PQ and PT are the same. Let's make a few examples. Now we are not afraid of these types of problems. We are armed with our theorems. And we know that we will be reading this and will be directing us to where we find solution. From any point outside the circle, only two tangents can be drawn and they are equal in length. This is the tangent, this is the tangent. Let's read it. PQ and PT are tangents. Stop there. It takes me to the three theorems that deals with the tangent. The first one is tan-chord theorem. The second one is tan-radius theorem. Remember, there are only three theorems that deals with the tangent. Tan-chord theorem, tan-radius theorem, and two tangents from the same point. Once we say PQ and PT are tangents, I think of those three theorems only. And I check if I do have those theorems in the diagram. Let me start from the bottom. Maybe let's look at two tangents from the same point. Do we have that in this diagram? Yes, we do. This is the tangent PQ. And another tangent PT. What is this saying to me? It says this tangent PT is equals to PQ. If these two are the same, what type of an angle is this one? QPT. It's an isosceles triangle. Now, if this is an isosceles triangle and these two are the same, it simply means that these two angles will be the same. If that is Y, this will also be Y. Remember, if these two are the same, and I add this plus this plus this, what do I get? 180 degrees. The sum of interior angles of a triangle. I already have 80. To get 180, what am I short of? I'm short of 100. And those two will be the same. So this will be 50, this will be 50. So this is how we'll go about finding the value of Y, that it is 50, by realizing that we've got two tangents from the same point that will make these two isosceles triangles, these two sides equal. It makes the triangle isosceles, and the angles opposite equal sides are the same. If this is Y, that will be Y. So this will be the same. So it's 50, 50 plus 80, it will give me 180, the sum of interior angles of a triangle. So that's how I will go about finding the value of Y. That's how we'll go about finding the value of Y. In this case, I've used tan radius theorem. Okay, in fact, they want us to find W first. Let's look at it. This is going here, and this is a tangent. So this value here will be 90 degrees. All right, that's fine. So I've already shown you how to find Y. Let's look at X now. Where is X? X is here. We already know Y. I mean W, which is 90, 50, X, 1, 2, 3, because this is a triangle. When we add these three, I must be able to get 180 degrees. We've got already the first 90. Let's find the second 90 from these two. So if this is 50, that will be 40 degrees. I've taken it from the sum of interior angles of a triangle. The sum of interior angles of a triangle. That's how we go about finding W. I think I've already spoken about Y, that these are the two tangents which are the same. Then I use the sum of interior angles of a triangle to find the value of Y to be 50. Angle Z. I don't have to stress about Z, I stress about theorems. Look at Y. Look at the position of Y. Where is Y? This is a tangent, this is a chord. Y is between a tangent and a chord. Now, an angle between a tangent and a chord is equal to the angle subtended by that chord in the alternate segment. So if this is 50, as we are told here, so this angle here, it's between a tangent and a chord. I'll go with my chord to the circumference. So this angle here is the same as this angle, tan chord theorem. So if Y is 50, therefore that will also be equal to 50 degrees. Right. Tan chord theorem, or angles in the alternate segment. Another problem, PQ and PT are tangents. These two are tangents, and they must be equal. So I know that this one is equal to this one, and there's no triangle, right? To a circle with a center O, center theorem. This angle is twice that angle. This angle 98 is 2 times that one. So Y, if I'm looking for Y, I've got to divide 98 by 2 to find angle Y. Let's look at the question. Question number 1. Find angle W. Angle W. Where is W? W is here. You don't have to think of W, think of the theorems. What is the name of this line? This line is called the radius. What is the name of this line? This line is called the tangent. What do I know about the theorem that deals with a radius and a tangent? Whenever a tangent meets a radius, 90 degrees is formed. Therefore, angle W is equal to 90 degrees tan radius theorem. Let's look at X. Where is X? Let me go look at X. What do I see around this X? This is the line. What is this line called? OQ is called a radius, and this line is called what? A tangent. Whenever a tangent meets a radius, what do we know? 90 degrees is formed. Therefore, this value of X here will also be equal to 90 degrees tan radius theorem. Let's look at Y now. Your eyes are the most powerful tool in your mathematics. Where is y? It is at the circumference. Do I have the angle at the center? Yes, I do have the angle at the center. This angle at the center will always 2 times bigger than the angle at the circumference. Therefore, y will be half of 98, which in this particular case will be 45. I've used the angle at the center, or the center theorem. Let me look for z now. We know that from our grade 8, grade 9, if I add this angle plus this angle plus this angle plus z, I will get 360, not 180 now. The sum of interior angles on every four-sided figure is 360. So we've got this as 90, we've got this as 90, so it's 90 plus 90 plus 98 plus z will give me 360. Therefore z will be equals to 82. I've used the sum of the interior angles in a quadrilateral. We've used that, the sum of interior angles in a quadrilateral. Alternate segment theorem, which is the tan-chord theorem. The angle between a tangent and a chord through the point of contact is equal to the angle subtended by that chord in the alternate segment. We abbreviate all this by tan-chord theorem. This is a chord, this is a tangent. The angle between a tangent and a chord. Let's have the angle between a chord and a tangent. Let's call it x. Now, to find the angle that will be equals to this x, I've got to take this chord and form an angle at the circumference. That is the angle. So this angle, which is formed by this chord at the circumference, is equal to the angle between a tangent and a chord. So if this is x, this angle that will be formed there will also be equals to x. I don't have to be stereotyped even if I'm coming from this side. I must be able to see that this y is between a chord and a tangent. I go with this chord to find the angle at the circumference, which will be this one. So this angle there will be the same as this one, tan-chord theorem. So that becomes crucial. Let's do a few examples. Find the missing angles below, give reasons for each. I'm given 45, I'm given 60, I'm looking for all the other ones. The first one that I'm looking for is the value of x. There is x. I take it back here. Look at this one. This is a tangent. This is a chord. I go with the chord to find the angle which will be equal to 45. In this particular case, angle 45, angle x will be equal to 45, tan-chord theorem. Let's look at what? Z. The next one is y. We're looking for y. Y is between a tangent and a chord. Ngizohamba ngale chord and find the angle that is formed by this chord, which is 60 degrees. Therefore, y is 60 degrees. Remember this scenario? These two are the same. These two are the same. It's exactly the same thing. Therefore, y is equals to 60 degrees. So that becomes very important. Right, even when we are looking for angle y, it will be equal to 60 degrees, subtended by this chord. It forms it at the circumference. Therefore, angle y will be equal to 60 degrees. Let's look for angle z now. This is where z is. There are too many ways. This is 60, this is 45. So this is a straight line. The sum of angles in a straight line are supplemental. So 45 plus 60 plus z will be equal to 180. That's one option. Option number 2, it can, remember this is also 45. 45 plus 60 plus z will be 180 if I'm using the sum of interior angles of a triangle. So I'm spoiled with choice. It's either I use the sum of interior angles of a triangle, which is 180, or I use the straight line, which is also 180. To find the angle z, which will then be equal to 75 degrees, the sum of interior angles of a triangle. So it's z plus 60 plus 45, which we find from here, plus 45 will be equal to 180. And that way we'll be able to find our angle z. Mixed questions. PTR is a tangent line to the circle T. PTR. Once they say PTR is a tangent, I think of 3 theorems that deals with a tangent. All right? Do I have 2 tangents from the same point here? No, I don't have. Do I have tan radius? This is a radius. This is tangent. Oh, I do have it. So this whole angle here will be 90. If this is 65, what should I add to get 90? This will give me the size of this angle. in that. Let me see what they are looking for first. And find angle SUT. SUT. We're looking for that angle there. And we're given this one. What forms that angle SUT? It is formed by this chord, ST. ST subtends angle U, the one that I'm looking for. And this one is a tangent, and this one is a chord. The angle between a tangent and a chord is equal to the angle in the alternate segment. So SUT will be equal to 65 degrees, the tan-chord theorem, or alternate segment. That's one. So we do have this angle as 65. What is the next question? SOT. SOT. Where is SOT? SOT. It is at the center. Do we have the angle at the circumference? Yes, we have it as 65. Which one is bigger? The one at the circumference or the one at the center? The one at the center is 2 times bigger than that one. If we have this one as 65, this one will be 65 times 2, which will give us 130 degrees. Because this one is the angle at the center, which is twice the angle at the circumference. So we do have this one, we do have this one. We're now looking for OTS. OTS, this small one. Remember that angle from there to here is a radius, and it meets a tangent. Therefore, this whole angle here will be 90 degrees. 65 plus what must give me 90? It is 65 plus 25. So this angle here will be 25. I've used the tan radius theorem. This is the radius, this is the tangent. Therefore, this whole angle will be 90 degrees. 90 degrees. So this one is actually 25. If this one is 25, what will this one be? Remember, this is an isosceles triangle. OS is equals to OT, radi, on the same circle. This one circle will have the same radius. From here to here is the same, from here to here is the same, from here to there. Radius is the same. So if these two are the same, therefore these two will be the same. So if I'm looking for OST, this angle, it is the same as OTS, which we've just found above to be 25. We've used the isosceles triangle. So that's how easy Euclidean geometry is. We are not afraid of such complicated problems. We are armed with our theorems and the statement. PR and P2 are tangents. There are only 3 theorems that deal with the tangent. These are the 2 tangents from the same point. I see them. Therefore, this side is the same as this side. UP is the same as PR from the 2 tangents theorem. If this is X, that will be X. I know that much. But let's find the questions first. Question number 1, find angle W. This is where W is. Okay, I can see a cyclic quad. Do you see a cyclic quad? Do you see a cyclic quad? You then go down, come this side, come this side. That's a cyclic quad. Yes, I do have this angle, which is 110, and this angle. All of that angle, W plus 48 plus 110 must give me 180. Right? W plus 48 plus 110 is equals to 180, opposite angles of a cyclic quad. If this is 110, whole of this must be 70. So 48 plus W must give me 70, therefore W will be equals to 22. Because 22 plus this is 70, 70 plus 110, it's 180. So the sum of opposite angles of a cyclic quad are supplementary. Just apply your theorems. Let's look at X now. We do have this as what? As what was our W? W is 22. We do have 22. What is this line called? It's called a radius. What is this line called? It's called a tangent. Whenever a radius meets a tangent, 90 degrees will be formed. We already have 22. So it's 22 plus what? That will give us 90. So X will be 68. 22 and 68 will give us 90 degrees, tan radius theorem. Let's look at this next question. I think they should be asking about y. Yes, they're asking about y. We do have our X as 68. Remember, we've got 2 tangents from the same point, which is point P. If this is equal to this, so x will also be the same as x there. So if this is 68, we've got 68 plus y will give us 180. Those three must give us 180. So 68 plus 68 plus y will give us 180. So the value of y in this particular case will be 44 because we've got an isosceles triangle. Right, we've got y. Now we're looking for z. Okay, look here. Look at this angle here. This is angle x. What is angle x? It is 68 degrees. Where is angle x? It is between a tangent and a chord. I go with this chord to the circumference. It will take me to angle z. So angle x is the same as angle z, tan chord theorem. So angle z will also be the same as angle x, which is 68 degrees. Tan chord theorem. So whatever I'm given, I know that I've got to use theorems to solve. These are some of the important people that studied geometry. Thomas Hobbes, Abraham Lincoln, US President, they all studied Euclidean geometry. Even Albert Einstein studied Euclidean geometry. Yeah, I want us to go straight to exam problems now. We were going to do the proofs of these theorems, but we'll do it some other time. I want us to go straight to problems.